This video will cover Chapter 10, Section 5, Reading Scientific Notation. The standards that this video aligns with are 8.EE.3 and 8.EE.4. The objective of this video is to use scientific notation to estimate very large or very small quantities. Here we look at a number that is in scientific notation. This number is in scientific notation because it has a factor of 8.3, which is greater than 1 and less than 10. It must be greater than 1 and less than 10 in order for it to be considered in scientific notation. And 8.3 meets these requirements. This is also in scientific notation because it has an integer exponent. -7 is an integer exponent. Remember, integers are whole numbers that can be either positive or negative. So an integer could be -5, 0, +5, so on and so forth. But a number like 1/2 or -1/2 is not an integer. And numbers like 0.01 or 0.11 are not integers. Fractions and decimals cannot be integers. Let's look and see if this number is in scientific notation. Here we see that it has a factor of 5.9. 5.9 is greater than 1 and less than 10. We also see that it has an exponent of -6. -6 is an integer. So this would be considered in scientific notation. Let's try another example. Here we have 0.9 times 10 to the -6 power. Here we see that 0.9 is less than 1. So this is not considered in scientific notation. Here we have 4.7 times 10 to the -1/2 power. 4.7 is less than 1 and greater than 1 and less than 10. So for this stipulation, our requirements have been met. But -1/2 is not an integer. So therefore, this is not in scientific notation. Notice that all numbers in scientific notation have the times 10 to a power. Now, when we are writing numbers in standard form, we look at the exponent, which here our exponent is -4. The exponent tells you how many places to move the decimal point. If the exponent is negative, then we move the decimal to the left. Here we see that we have a -4, so we're going to move our decimal to the left. So we move it 1 place, 2 places, 3 places, and we put zeros in the empty spots. So now our new number is 0.00322, and we drop our times 10 to the -4th because it's replaced by moving the decimal. Let's try another example. Here we have 7.9 times 10 to the 5th power. Since our exponent is positive, we are going to move our decimal point to the right. So we'll move it 1, 2, 3, 4, 5 places to the right. So our new number is going to be 7, 9, and we would add zeros into the empty spots. So we would add 1, 2, 3, 4 zeros. And this would be our new number. For further assistance, read pages 438 through 439. Here there are examples that are worked out step by step, explaining how to complete them. Your homework problems that are to be completed before class are on page 440, problems number 6, 7, 8, 9, 15, 16, 18, and 23. This is to be completed before September 18th, which is a Friday. These must be turned in at the beginning of class on Friday, September the 18th.